Okay. Earlier on in the year, in semester one, we learned how to rewrite equations in multiple variables. And I'm going to do a little tutorial on the bottom, and then we'll get rid of it and write the result at the top. Okay. We know that direct variation equations are written in this form: equals kx. And we, if we wanted to, we could isolate k by simply dividing both sides by x. If we took this and we divided both sides by x, writing it like this: y equals kx, and then divided both sides by x, you can see that the x will cancel out on this side, and we will get, whoops, y over x is what k is equal to, or we could write it as k, switching sides, is equal to y over x. We can find the value of k by dividing y by x. So this result right here, I'm going to write at the top, and we're going to use that as the basis for the problems 15, 17, and 19 right now. So I'm just going to get rid of all this and type this at the top. Okay, so you see that I've transferred this information up to here. This looks maybe a little bit funny because of the way that it's typed, but that is the same as this, just a y over x. Okay, that's what it says up top. K equals y divided by x. Okay, so the idea here is that we want to write the equation y equals kx, the original equation that we're going to be using, y equals kx, but we don't want to have the letter k. We don't want it to be left as a variable. We want to actually use the numbers that they're giving us right here and use that within this to find out what k is, so then we can write y equals something x with an actual number on it. So in order to find k, we say we're going to use the equation like up top. K is equal to y divided by x, and they're giving us values for y and x here. For number 15, it says, suppose y varies directly with x. That means we know we're dealing with a direct variation situation. We're going to write the equation that relates these two numbers that they've given us here. Y equals -10, x equals 2. Okay, and we're going to do that by plugging it into here. So k is going to be equal to, the y value is -10, and the x value is 2. So if we have -10 divided by 2, then we know that k must be -5. That's what we're going to use. We found the constant of variation, so then we have an equation that says y equals -5x. Okay, that's the instructions that they give us here. Write a direct variation equation that relates y and x. Well, you take x, you multiply by -5, you'll get y. And if you can see that here, we can take x, we multiply this x 2, multiplied by -5, it's -10. Okay, and now solve for y when x is 12. So now that we've done that, we're going to plug it in. We're going to say y equals, and we're going to substitute x with the number 12. That number is the number that they're giving us up here at the top that they want us to use each time. So, okay, so y equals -5 times 12, or y equals -60. Okay, so we did that. Actually, I'm going to box the two things that they ask us to do. They say write a direct variation equation, and then find the value of y when x is 12. So what's the direct variation equation? It is this right here in blue. And what is the value of y? It is this right here. So you should have as an answer y equals -5x and -60. Okay, I'm going to draw a little dividing line and we'll do the next one. Okay, now we're going to return to this same equation, which is the equation that we use to find the k value. K is equal to the y value divided by the x value. And this is a simplification of what you'll know later as y2 minus y1 over x2 minus x1. Because really, in direct variation equations, we always have 0, 0 as one of the points that goes right through the origin. So you could just as easily say y minus 0 over x minus 0, and that's the same as just y over x. So this simplifies that normal how do you find the slope equation. Okay, anyway, we need to solve for the k value first. So k is going to be equal to y, 5, over x, 2. So now that we solved for that, we can then write the equation as, and I'm going to write it in blue because it's underlined in blue what they ask us to do up top. So what I'm going to say, okay, so k is equal to, I'm sorry, not k is equal to, y is equal to 5/2 x. It's one answer that they want us to have. And then we're going to need to plug that back in. We're going to say y is equal to 5/2 times, what did they want us to use for x? Well, that's what's in green up there. They said use 12. Use 12 as the number. What are you trying to find? Y when x is 12. So if we do that, we then get y is equal to really 5 over 2 times 12 over 1. And we can then simplify that by canceling, dividing both by 2. That becomes a 1. That becomes a 6. And then when we multiply, we get y equals, we're going to get a 1 on the bottom, so we can just call it the whole number that we get on top. And here, 5 times the 6 that we got when we canceled is 30. So y equals 30. That's the green answer for the top. Find the value of y when x is 12. Okay, I'm going to do a dividing line, and we'll do the last one. Once again, last one, we need to find the constant of variation. We need to find the k value. So we start with k is equal to the y value that they gave us divided by the x value that they gave us. Okay, so plugging those in, we say k is equal to, what did they give us for y? They gave us 10.4. What did they give us for x? They gave us 4. So then here we're just going to do a little bit of division so that we get a decimal number for the k value. So if we do, I'm going to write and then I'll erase, okay? But if we do 10.4, oops, sorry about that. I'll get a better color than that. If we do 10.4 divided by 4, we say 4 goes into 10 2 times, that's 8. Bring down the 4. 4 goes into 24 6 times. 6 times 4 is 24. And the decimal goes straight up to become 2.6. So the k value is, as a decimal, 2.6, and we'll use that to write our equation. So k equals 2.6. And we get then as an equation, which I'll write again in blue because that's up top. Underlined in blue is what they're asking us to do, which is write a direct variation equation. We get y equals 2.6 x. And then we're going to take that equation and we're going to plug in the value they want us to use for x now, which is 12. And we'll say then y equals 2.6 times 12. Let's do a little math on the bottom just to figure out what that number should be. And then I'll erase it. So we'll say 2.6 times 12. 2 times 6 is 12. Carry the 1. 2 times 2 is 4 plus 1 is 5. 0 placeholder. 1 times 6 is 6. 1 times 2 is 2. Bring down, I'm sorry, 2 plus 0 is 2. This is 11, carry the 1. And in the answer, I'm sorry, in the original problem, there was a single digit that was behind the decimal. So in our answer, we're going to get a single digit behind the decimal for an answer of 31.2. So I'm going to erase that. And we get, I'll put it here in blue, or sorry, in green, y equals 31.2. And just to recap, as a fun fact, we know that we had, and I'm going to choose another color here and see if I can do this to just separate it from all of the other stuff that we're doing. But we had a point, essentially, if we were going to graph this, here at the top for number 15, 2, comma, negative 10. Okay, that's an x and a y value for this. We also found out that if we used 12, we would get 12, comma, what does 12 result in? It results in, down on the bottom in green, negative 60. So that's another point that would be on this graph. So whenever you want to graph a line, you have 2 points. You can use 0, comma 0 and the original point they gave you. But this is another point that would also be on the line that you would graph. And if we continue doing that, for number 17, we'd say, okay, we had the point 2, comma 12, sorry, 2, comma 5, the information they gave us. X is 2, y is 5. And then they said, what would you get when you had 12? Well, it would be 12 as the input, 30 would be the output. So that would be another point that would be on the graph. And finally, here for number 19, we would have gotten a point that's on the graph of 4, comma 10.4. That point will land on the graphed line. And they asked us to say, what would you get as an output if you plugged in 12? So we would have 12, comma, and what did it result in? 31.2. So all of those in orange that I just wrote there, or yellow, depending on how it appears to you, would be points that would be on the graph if we graphed these direct variation equations. So, yep, that was full of information, but watch it a second time if you need to, and hopefully it's helpful.